We import regex for text cleaning, FastAPI components for the web framework, HTML response and Jinja 2 templates for rendering pages, Pydantic's base model for request validation, TF-IDF Vectorizer to convert articles into numerical vectors, Logistic Regression as our classifier, and the labeled news datasets from a local data module. We initialize the FastAPI application with a descriptive title and configure Jinja 2 to serve HTML templates from the templates directory. We define a text cleaning function that lowercase the input, strips out URLs, removes all non-alphanumeric characters, and collapses multiple spaces into one, producing clean normalized text for consistent vectorization. We clean all training articles from both datasets and build a matching label list, one for every real news article and 0 for every fake one, so the model learns to distinguish between them. We initialize a TF-IDF Vectorizer that captures up to 5,000 of the most important single words and two-word phrases while filtering out common English stop words, then fit and transform all cleaned articles into a numerical matrix. We train a logistic regression classifier with up to 1,000 iterations and balanced class weighting, which compensates for any imbalance between real and fake news samples on the TF-IDF feature matrix. We define a list of common clickbait and misinformation phrases that will be used as rule-based red flags to boost the fake score when detected alongside the ML prediction. We define a Pydantic request model that validates the incoming JSON body, ensuring the article text field is present and typed as a string before prediction runs. This get route serves the homepage, rendering the News Detector UI where users can paste an article for analysis. This post route receives the news article text, strips white space, and immediately returns a validation error if the input is too short to produce a meaningful prediction. We clean and vectorize the raw input using the fitted vectorizer, run the model to get class probabilities, and convert the fake and real scores into percentages. We scan the article for suspicious phrases, add 4 percentage points to the fake score for each flag found while capping it at 99%, and recalculate the real score as the complement, ensuring the two scores always sum to 100. We determine the final verdict by comparing the adjusted fake and real scores, labeling the article as fake if the fake score dominates and real otherwise. We return a JSON response with the verdict, overall confidence as the higher of the two scores, both individual scores, up to 5 detected suspicious phrases, and the article's word count for the front end to display a complete analysis. Now here is our index.html where I have designed the all-user interface. If you would like access to this code, just send me a message on our Discord server.